Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 704. Please turn to it, page 704, and today is our lesson number 79. Problem number 17 is what we are dealing with. I have put the graph on the blackboard ahead of time. It says the graph of the function f of x is shown. It is given to us. As we can see here, there are some points that are given to us, a couple of points. For example, if you look at the graph carefully, you will see that when x is equal to 0, y is equal to 1. And I have given that point a name. They do not, in the picture, in the graph that they give us, they do not give any points a name here. I have given them names so that it's easy for us to discuss these points. So I've called that point A. Similarly, if you look at the graph that is given to you again, and you have to have the book in front of you, look at the graph and you will see that when x is equal to 1, y is equal to 0. I'm calling it point B. Point C is something that is not shown in the book, that do not actually indicate point C as such, but somewhere here would be, if this is x equal to 1, then this will be x equal to 2, and then x equal to 3. When x is equal to 3, if you go up there, you can assume, you can pretend that y is equal to about 3. We don't know exact value of it, let's just assume that it's 3. So that's your point C. The question here is, what will happen to this function if we were to modify it? Instead of y equal to f of x, our new function is y equals to f of x plus 2. All that means is that, because of the fact that now we have added 2 to the x, all that means is that whatever the value of the function was before, for a given value of x, the same value, the new function will have the same values when x is now 2 units less than before. For example, before when x was 0, the y was, when x was 0, y was 1. Now, the same exact thing will happen 2 units earlier. Instead of x being 0, now x will be negative 2, and the y will be 0. So this is our old function, original function. This is our new function. Why does x has to be negative 0 for y to be 0? Because that's the only way we're going to make this equal. You see, y is equal to 0 in the old function when x is equal to 0. We have to make this quantity into 0. How do we make this quantity in the parentheses equal to 0? When x is equal to negative 2. Negative 2 plus a 2 will give us f of 0. And we know that f of 0, when x is 0, y is equal to 1. Except x is not 0 now, x is negative 2. When x is negative 2, f of 0 would be the same as before, which is 1. So the same value of y will take place. That should have said 1, not 0. The same value of y will take place. Y is equal to 1 before when x was 0. Now the y is going to be 1 when x is negative 2. Similarly, if you take one more point, before when x was negative 1, y was positive 1. If we subtract 2 from the value of the x, it becomes negative 3, and y would be positive 1 at 3. Y will be positive 1 when x is equal to negative 3. Again, you can see that right here. When x is equal to negative 3, negative 3 plus 2 is same as negative 1, and therefore the function will have the same value. The function will have the same value as the value that function had when x was negative 1. When x was negative 1, y is equal to positive 1. Let's do one more before we plot it. Let's take something here. Why don't we take this one here? When x is equal to 1. Before, when x was 1, y was 0. Now, positive 1 minus the 2 will become negative 1. Now the same value will take place when x is equal to negative 1, and y would be 0. Let's plot this point. I'm going to erase this part here, but before I erase it, I'm going to read it one more time. What it means is that by virtue of having 2 in it, x plus 2, what it means is that whatever the value of the function was before, for a given value of x that is, now the new function will have the same value when x is 2 units less than before. It's the same drama, same scene taking place. It's the same drama. Think of this as a play, same drama, same scene. It just takes place 2 minutes early. That's all. We have changed our starting time of our drama. Instead of starting at 9 o'clock, we have started our drama at 8:58, and therefore every scene takes place 2 minutes earlier than before. That's what it is. That's what that means. Let's plot it. See what it looks like. Let's plot it. So this is our original graph. Now here's our new graph. Watch what happens. I'm going to do point by point. Here's our point A. When x is equal to 0, y is 1. Instead of 0 now, the same thing is going to take place when x is equal to -2, because 0 minus -2, when x is equal to negative, because it happens 2 units earlier. So -2 and x is 1. That's our point A. Before, when x was 1, y was 0. Instead of 1 now, we're going to go 2 units, we're going to subtract 2 units. It's going to take place, this unit will occur 2 units earlier, 1 and 2. It will happen in -1. Before, when x was -1, y was 1. Now it's going to be -3. 2, 3, -3. So that's your point. Let's give this point a name. Let's call it D. And this was point C. Let's do point C now. Before, point C took place at 3, 3. Instead of 3, 3, now it will take place at 1, 3. 1 and 3. So this is 1, 2, 3. Somewhere here, point C. And this is what the graph looks like. So what has happened to it? What has happened to it? X is equal to, when x is 0, before when x was equal to 0, when x was equal to 0, y was 1. Now, when x is equal to 0, y is still 1, but this point that we see here, is not this point, it's not point A. Point A is here. This point that you see here is this point right here. When x is 2, it's getting too crowded. See here? This is 2. That was 3. This was 1. So before, when x was 2, y was 1. Now the same value they see here, 2. When x is 2, y is 1. This value, let's give it a point. Give this point a name. Let's call it E. That point E shows up here. So what has happened to the graph? What does it do by adding? Instead of having f of x, what happens when you have f of x plus 2? By giving 2 points, by giving 2 extra units to x, think of it in this way. By giving 2 extra units to x, x has to be 2 units less than before, to compensate for the fact that we are adding 2 to it. To compensate for the fact that we are adding 2 to the value of x, therefore x has to be 2 less than before to compensate for it. And therefore the entire drama takes place 2 minutes earlier, or 2 units earlier. And this is the graph. In essence, what it means is that we have the same graph as before, except we pick it up, we literally pick it up, and we shift it to the 2 units. That's all it means. That's all it means. So do you see a graph where it looks like we have picked it up and shifted it to the left 2 units? You see any graph at all that matches this description? And that graph would be something that looks like this, and that's point C. That's answer choice C. The answer is C. That's all. I'm not going to keep explaining it more and more because I don't think we have already done the job. It will get to be too much if I keep repeating the same thing. So that was it. The answer is C. Same exact graph, except it's shifted to the left by 2 units. Let's do number 18. Number 18. Number 18 is a hard question. They have classified as a hard question, and we have a triangle here. Let's see what it does. A, B, and C. We are told that AB equals BC. AB does not look like A equals to BC. I'm going to redraw it. AB equals BC. Alright. AB equals BC. So these two sides are equal. Before we do any work at all, what does it tell us? What does it imply? What does it suggest? It suggests that if AB equals BC, that suggests that this angle must equal that angle. What else do we know? So these two angles are equal. Angle A equals angle C. What else do we know? We also know that angle ABC, angle ABC is 30 degrees. This is 30 degrees. This is very helpful. If the top angle we are told that angle ABC equals 30 degrees. The letter that appears in the middle, is the letter that they're talking about, angle ABC. That angle is 30. If that is 30 and if these two angles are equal to each other, and since the sum of the angles in the triangle has to be 180, the sum of A and C has to be 150. Therefore, each of these are 75. Okay? Now we'll worry about the one inside. Now we have taken care of the bigger triangle. Now we look at the inside one, which is why I skipped over the inside part here. So now we look at the inside triangle, which looks something like this. Oh man, I'm not doing a very good job of drawing it. See, the way I drew it, it would have looked like this, but it wouldn't change anything. It does not change anything, except theirs is slanted. It doesn't actually change anything. It doesn't change the fact that D, F, E. Actually, it does change the fact because anyway. So in triangle DEF, we are told that DE equals EF. See, D to E, this side equals E to F, and we also told that it is equal to D to F. In other words, what we are told here is that the triangle DEF is an equilateral triangle. Equilateral triangle. Now, if the triangle is an equilateral triangle, what do we know about the angles of the equilateral triangle? The three angles would have to be equal to each other. That's what equilateral triangle means. And since the sum of the angles in a triangle is 180, since the sum of the angles of any triangle is 180, in an equilateral triangle, since all the three angles are equal to each other, they are all 60 degrees. So now we know that this is 60 degrees, this is 60 degrees, this is 60 degrees. Okay, we're getting very close to getting done, so pay attention. What else we are told? We are told that BDE, we are told that angle BDE equals 50. Let's find out where BD is. Here's B. BDE. This angle equals 50 degrees. Okay? If angle BDE equals 50, and we know that angle EDF equals 60, angle EDF equals 60, that's this angle right here, and since the straight line makes 180, therefore angle FDA or ADF must equal 180 minus 50 minus 60. 180 minus 110, which is 70 degrees. This angle right here is 70 degrees. What is the question asking for? There you go, that's what they're looking for. They're looking for angle DFA. This angle ADF is same as D. Oh, they're looking for this angle actually. We're not quite done yet. They're looking for the angle in the bottom here. They're looking for DFA. So now we know. So let's continue here. In triangle ADF, we know that angle ADF. ADF equals ADF. This angle equals 70. We also know that angle DAF equals 75. Therefore, the angle that they are looking for, which is DFA must equal 180 minus 70 minus 75. 70 plus 75 is 145, so 180 minus 145 is 35 degrees. There we go. By golly, you finally got it. It is 35 degrees. The answer is B. The answer is B. Do you understand? That's all. What I'm going to do now is that I'm going to actually redo it, but I'm going to do it at a faster pace without writing anything, because sometimes you try to write everything and you try to explain every tiny little excruciating detail, it gets to be really painful. Do you understand? Which is probably why it's called excruciating detail. So I'm going to redo it, but at a little bit faster pace and see what happens, okay? We're going to start from scratch and we're going to redo it. Here we go. I'm not going to erase anything because the thing that we talked about will still hold. So everything that you see here will still hold, except here is what's going on. It's A, B, C. The first thing we are told is that AB equals BC, which means this angle equals this angle. We are told the top angle is 30 degrees. We are told that angle ABC equals 30 degrees. They must tell us there somewhere. Angle ABC equals 30 degrees. Where did they tell us? There you go. Angle ABC is 30 degrees, which is top part here. Let me rewrite this thing. It looks kind of ugly. So if angle ABC is 30, and since these two are equal to each other, they must be 70 each. They must be 70 each. Now we put our triangle there, and now I'm going to do it a better job of it. I'm going to put it at a slanted angle a little bit. It's still not coming out right. Oh, for Christ's sake. There. We are told that this triangle is equal to each other. The sides in this triangle are equal to each other. If the sides in this triangle are equal to each other, then each of the angle must be 60. This is 60, this is 60, and this is 60. You still with me so far? Very good. So that's 60, and then additional bit of information that we are told is that the angle BDE, we are told angle BDE right here, this is given. This part is given to us. We are told that angle BDE, this angle is 50. Okay, watch what happens now. If this angle is 50, BDE is 50, and EDF is 60, then this part ADF must be whatever is left over from 180. 50 plus 60 is 110. 180 minus 110 is 70. So that means this angle must be 70. Didn't we get something else last time? Yeah, 70. And the mistake, I just realized what I did here, because all of a sudden I remembered that in the previous solution we did not, I did remember distinctly that triangle ADF did not turn out to be an isosceles triangle. The way I have it written here, it's an isosceles triangle because this is 70 and this is 70. And that's how I caught my mistake here. Angle A and angle C are not 70 because 70 plus 70 is 140. 140 plus 30 does not equal to 180. Since this is 30, the remaining is 150 and these are 75 each. These are 75 each. And that's how we're going to get a wrong answer in this question, by not paying attention like I just did. I was careless, and you will obviously go off by 5 degrees. And that's what they're hoping that would happen here, because they give you 30, 35, 40. So you have to pay attention. You have to pay very close attention. Otherwise, you're going to end up making a mistake like I just did. So this is 75, this is 70, and therefore the remaining angle would be 180 right here. 180 minus 70 minus 75, which is 35 degrees. This angle that we found out, that's our payoff. That's what they're looking for. And that's all there is. I will see you tomorrow, okay? Bye now.